unit 5, which is the sources and preparation of indoles. So at the end of the session, you should be able to state 3 sources of indoles. You should be able to at least state 2 uses of indoles. You should be able to describe the industrial preparation of indoles. And lastly, you should be able to write a general equation for the synthesis of indole. First of all, we are going to look at the sources and uses of indole. So, on the sources, right? Indole is a heterocyclic organic compound which is released directly into the environment as a component of tobacco smoke and occurs naturally in coal tar, in jasmine oil, and other fecal matter. So these are all sources of indoles, and on their uses, there are quite a number of them, right? So they are used in the making of perfumes, dyes in the agrochemical industry, making some pharmaceutical drugs, right? They are also used in making tryptophan, an essential amino acid. They are also used per-indole acetic acid, which are auxins, and some plant hormones which help in the development of roots and shoots as well. Okay, so next is to quickly look at the industrial preparation of these indoles. So the indoles themselves and their derivatives can be synthesized through different means, right? The industrial route is basically aniline, which is reacted through a vapor phase reaction with ethylene glycol in the presence of a catalyst. Now, in general, the reaction is conducted between 200 and 500 degrees Celsius in this range, and the percentage yield is almost always 60%. So we have our aniline, which is first of all, the aniline is first of all reacted with ethylene glycol in the presence of a catalyst at this temperature to produce this. So cases where you want to synthesize some derivatives, then our power groups can also come in as the starting material to react with our ethylene glycol in the presence of a catalyst to give us our indole product. Next, we are going to look at the Fischer-Indole synthesis, which is used to synthesize a wide variety of derivatives of indoles. Here, we treat a phenyl hydrazine or a substituted hydrazine of an aldehyde or ketone with zinc chloride in phosphoric acid or any other mineral salt or Lewis acid to produce our desired heterocyclic compound or indole derivative. So, the process is a ring closure followed by the elimination of ammonia, giving us the required product. So this is the typical reaction equation to take note. So depending on the kind of indole derivative we want to synthesize, that will inform us of what substituents to put on our starting material, right? Okay, so we can quickly look at the mechanism of this reaction. There are some different various mechanisms, but then the Robinson mechanism is the widely accepted one. So it begins with the acid catalyzed rearrangement of our aryl hydrazine from its imine form to its enamine form, right? So first of all, the two basic nitrogens you see here are probably protonated in strong acidic medium to form the activated system you see here, which then undergoes the rearrangement using one of the pi electrons or the pi bonds from the benzene and the double bond from the imine group, right? So these two bonds undergo the rearrangement to produce the subsequent product you see here. Now, this product is then deprotonated to give the benzene amine product. So this is the benzene amine product, and this is also followed by an intramolecular nucleophilic attack to produce a ring form, first heterocyclic, which is saturated. It's also known as the benzene amine substituent as well, which leads to ring closure. So when this is formed, the benzene amine is formed, is deprotonated to produce the ring form. Now this ring is followed by the loss of an ammonia and a proton to give the aromatic indole. So we have the removal of ammonia or ammonia elimination, followed by the loss of a proton to produce our final indole product. So this process by the Robinson mechanism is the widely accepted catalytic mechanism for the synthesis of our indoles, right, together with their derivatives. So we have the aryl hydrazone, which is being converted from its imine form to the enamine form. So this is just explanatory to the other explanations to support the mechanism of the indole synthesis, Fischer indole synthesis by the Robinson mechanism.